Hello and welcome back to the lab. This is I've been doing some videos, but most of them have been check-in and calibration videos. There hasn't been much repair. I've been trying to source some broken equipment, but the equipment hasn't really been broken. So it's just been check-in, function check, and repair. This is a 7A16A plug-in for a 7000 series scope. We'll crack it open and take a look at it. This is reportedly broken, so we'll see. See if we can duplicate the effect. What I've been told is that any multiple of 1 or 5 doesn't want to work. So we'll give it a shot and see what we can find. See what we can tear into on this one. I'm not too familiar with the 7A16s. I have a lot of 7A15s. They are absolutely identical plugins, except this has a push button that comes out here, where this one is set. It's a cal detent. I think there's a bandwidth difference between the two. I'll have to look up a spec sheet and see what's going on there. But yeah, so first off, what I'm going to do is I've got a function generator up in the TM500. It's just a 501, so we'll just plug some signal into this and see if it flattens out like it was reported. So I got the spot open, and there's the 7603. So we'll get this tossed in there, and then actually I'll just do that on camera. We'll just put this in here real quick. Turn that on, and I'll let that warm up for a little bit. I'll get some cables, and we'll feed some signal into this and see what this plugin decides to do. Okay, so I have checked the signal. I know we have signal. Sorry about the camera. I know we have signal. I know we have a good cable. This is the 7A16, so we'll flip this to AC, and we have that's really interesting. Okay, so what's interesting is I did check this on the Rigel, and I'm just double checking everything. So if I take, oh, there's the problem. Didn't have the probe set right. It's off by a factor of 10. So we do have a decent amount of signal coming from my function generator, and we have a nice clean sine wave, no noise. If I move this a little bit, there's a little noise in the switch, but that's typical with cam switches. Do have control on the variable. If I go to DC, we do have control. Full bandwidth, 20 megahertz. Bandwidth limit's fine. I can invert the polarity. So that looks like it's working. So now, if the error is correct, if I flip it to here, signal goes 100% flat. If I go to 2, it comes back. If I go to 1, it's not there. Bring that down a little bit. So .1, no signal. 500 millivolts, no signal. 20 millivolts, we have signal. 10 millivolts, we have no signal. And 5, we have no signal as well. So we can verify the fault in the plug-in. So let's, first off, let me pull it out. We'll get it under the microscope and we'll do a visual inspection and just see if anything jumps out at us. Not sure exactly what we'll find yet, because at this point you guys know as much as I do on this thing. So, okay, so here's the inside of the plug-in. Everything looks actually pretty clean inside, and there's no big giant dust bunnies or anything like that. A couple of things I noticed right off the bat is, unlike the 15, this one, that one, that one, and that one, these are all custom Tektronix ICs or hybrids. A lot of people call them different things, but these are going to be custom parts. If anything is wrong with those, they're going to be difficult to source. Don't really see many of the cannulums that tend to go bad on these. There's like one right here, and I'm not really seeing any more. Everything looks okay, at least on this side of the board. Nothing's burnt, blown up, broken, things like that. These are the attenuator networks. So we have two 10x attenuators, we have a 5x attenuator, and we have a 2x attenuator. I did check, if I rotate, it's real hard to see. I'll pull all the attenuators out so you guys can see the finger switches. The finger switches are going up and down, so the cam, which is actually on the back here, is in good shape. So I'm going to open up this 2x attenuator and see, because I have a sneaking suspicion our problem in this plugin is in these two attenuators, because these are working okay, the 10x ones. So let's take a look. We'll see what we can find. So I will reposition the camera and then I'll be right back. Well, it does seem by the time stuff reaches my bench, the easy stuff is already gone. So what I've done so far is I've injected, right at the input, I've injected some signal. And I did a resistance measurement on the attenuators, and they sanity checked. I don't know what they're supposed to be, but they sanity checked. I actually should not have taken this attenuator apart. That's the one that works. But I did manage to get it put back together, and it does still work. The goofy part is, so in following the signal comes in here at J10, runs through the ground AC and DC switch is working, runs through, pops out here at Q150A, which is a 2 FET unit. Here's the other part, so here's A and B. That is this FET right here. So this is A and B in a single package, and I can get to it back in here. You guys cannot see that. There we go. So I can get to it from back in here. So so what's going on with this thing at the moment, besides one of my Rigol oscilloscope probes dying on me, is if I have the attenuator in a multiple of 2, so 20 millivolts, 20.2, 2, it works. If I have the attenuator in any other settings, I lose the signal at this FET. So I have no signal here. So my problem is somewhere in here, and I'm actually starting to think it's somewhere in this gang switch. I have to go through this truth table and figure out what's going on. Also, it could be a couple of these resistors to ground which are shorted, and because there's a couple of resistors in here too, so there could be a shorted part in here, but I'm going to have to tear into this attenuator switch too to get some of that. So anytime the attenuator is multiple 2, it's dead, and I do lose it here. So the rest of the plug-in, I think, is working. I think our problem is somewhere in here there is an error, shorted part or something like that, that's only switching in or switching out when something 2x is set. I'll have to see what's open and what's closed. Now, the other thing that I have noticed is the readout's actually working. So if I switch it around in the readout, it is reading correctly. So it's at least halfway working, but I am going to have to disassemble this cam switch because there's some parts in there that we need to look at. So I will get that done, and I'll let you know what I find. The current state of the bench. So we've actually made some progress. I'll show you guys what I found. I had to tear this thing down pretty far, and I'll get back in there and show everybody here in a second. So I have signal on a 1 range. So we have 1 back, and so we have 1 attenuators. We also have 2 attenuators. If I flip it to 2, it'll work. But however, the scope is telling me this is 100 millivolts per division. That's not 100 millivolts, or that's not a 1 volt signal. So if I move this, oh, it is. No, that's right. I had the 100 millivolts of division, 100 millivolts of division. If I come up to the Rigol, this was my problem. I had probe hooked up, so I had the compensation off. The tech scopes will do that automatically. If I plug in a 10 meg probe, this will kick over to 1 volt per division. I have to tell the Rigol, because if I tell the Rigol 10x, it tells me 1 volt per division. But because I'm feeding signal in, it needs to be 1x. So we have the same signal on there that we do in the plug-in, which is down there. But if I wiggle, so what I'm going to do is, if we take a look, I will just wiggle this right here, which is the knob, and watch the trace. If I move, yep, there it goes, lost it, push it up, have it, push it down, lost it, push it up, have it, push it down, lost it. So if I wiggle this, so there's a loose connection in that cam switch. So what I'll do is, and I'll do this on camera, I'm going to pull the cam switch back apart so you guys can see how far down it had to come apart. I'll adjust the tension. Again, I'll add some tension to the finger springs. I'll do it on both sides, the attenuator side and A side and B side. And hopefully put this thing together, and we may have a functioning plug-in, assuming we can calibrate it. I've moved all kinds of stuff around, had things all over the place. The cal is nowhere close on this plug-in, so we will have to align it after I get done repairing it. But it's very good that we have signal back. Let me grab a quick pair of pliers here real quick, and I'll just see if I can get, there's 2 still, so we still have 2. Let's see if I can get, there's 5, and we actually have 5 back too. So yeah, it looks like that. Looks like part of the problem on this, sorry about the phone, we have 5 back too. So looks like the problem on this was a spring tension problem on the fingers. They'd gotten weak and they weren't making contact. There's a rail in the back, which I'll show you guys here in a second. So I'll get this whole thing pulled apart. I will turn this down so it doesn't burn in my screen. I'll get that torn back down apart, and I'll shoot some video of the attenuator of both sides of the finger section while I do the adjustment, and I'll show you how I'm going to do that adjustment, and I'll get that done, and hopefully we have a plug-in. I did get the service manual for this plug-in. This is a 150 megahertz plug-in, so 150 megahertz single channel. That's the main difference between it and the 15. 15 is a 75 megahertz. This is 150 megahertz. So let me get that all torn back down, and then I'll bring you guys back, and we'll take a look and see what it's doing. Okay, and here are the infamous Tektronix finger switches. Let's try to hold this here real quick. Let me tilt the camera down. There we go. So, what happens is, let's see, there it is. This piece of plastic with these ridges sits in like this, and as the ridges roll around as you set things on the dial in the front, the ridges on the roller actuate the switches by pushing on these plastic pieces. Now these finger switches are connected to a mating finger switch on the other side of the board, so when this one gets pushed down, the other one gets pushed up. So that's what switches the attenuators, because these are actually the bottom side of the attenuators, in and out of the network. Because for the high bandwidth amplifiers, what they do is the amplification rate is set. They knock the signal down coming in, so there's a fixed gain for the bandwidth. And then they knock the signal down coming in to get the different voltages per division. This is actually where the variable shaft connects. Actually, I have that. That's right here. So this actually slides in just like so. The cam switch is hollow. You see right through it. Slides all the way back. To here, and just locks in that coupler right there. So, and then the off and on, there's a switch in this. There's a switch and a pot in this. So you have a pot that turns, and then you have a push button switch that moves off and on. These work really well. This is a very good design. Nothing wrong with it. Everything works really, really well in this. Until it doesn't. This plug-in's older than I am, so that's a testament to the design. The spring tension on these little fingers has died over the years. The way I adjust it is I take an Allen key, the short side, put it right underneath, and just push down on the top with a plastic tool. Now, you want to be real careful with these. You don't want any kind of finger oils or oil or anything like that. All these finger switches are made to be kept dry. These are high-frequency switching, and this U is the finger switch. This is just a spring relay, so this isn't even connected. They're held together with the plastic coupler. They stop right here, so the finger switch is not connected to the ground plane, so you have ground all the way up here, finger switch, into finger switch, and what you can't see is this line is broken. There's a space here and a space here, so when these two finger switches are down, it shorts the rail to continue going. And this is where it leaves this board and goes into the rest of the plug-in. Per the manual, this is a very special board material. Do not use anything harsher than isopropyl alcohol on these. You can actually damage the board material. That's per Tektronix's service manuals. So only clean these with isopropyl alcohol, nothing more aggressive. You don't want to wear any of this gold plating off, so no scratch pads, no anything like that. Isopropyl alcohol and actually a piece of blotting paper, just moving it back and forth slowly. And you actually want to move it in line with the switch this way. You don't want to move it this way, because if any of this gets bent, it'd be very, very hard to straighten again. That's this side. The other side is the same thing. You can see more of these micro switches. Because I've had my hands all in here, I'm going to pop these out. I'll adjust the spring tension on the micro switches as well, or on the switches up here. And then I'll hose this all down with isopropyl. I got that aerosolized can of ISO. We'll hose this down, run it through the ranges, just make sure we get some signal through it, and then we'll try to calibrate it and see what happens. The calibration will tell us if we have other issues we need to address. So other than that, we do have signal back in the plug-in, so let me pop these out, and I'll get an Allen key, and I'll show you how I adjust the tension on the finger switches. This is only a 150 megahertz plug-in, but they use these finger switches all the way through the 500 megahertz plug-ins. The same finger switches, so they're really good for high frequency stuff. They're just really fragile. Let me get going on that, and we'll see what happens. I will be back in a minute once I clear the bench. So, extreme close-up. Okay, so the two tools I use for this is I use a Allen key and I use a plastic spudger. And this is all we need. And just to give you an idea on how big this stuff is, I'll get some size perspectives here in a little bit. But all I do is I take the Allen key, and I hook it under the fingers, and I want the Allen key as far back towards the plastic as I can get. So I don't want to do this out here. I want to do this back towards the body, and then I just take the spudger and I lightly just push down. All I'm looking to do is bend those switch contacts ever so slightly. And that's perfect. You want to be straight. And that should be good. And then I push them down just to kind of see, yeah, there's a lot of, yeah, they have that rubbing action when you push them now. So they're making good contact again. If you watch as I push, you can't see. I'll do it up here. Drop my tool. Come here. Doing this around the camera and the tripod is not easy. So to make good contact, if I push this down, you'll see they just made contact, but then if they keep going, they do this kind of rubbing action to do some self-cleaning just a little bit. So that's making really good contact now. There's travel on there. I got to do the rest of them that are under here. Flip it over, do the same thing on the other side. And then we'll just see how the plug-in works. But I'm going to hose it down because I actually have the cam switch open. I'll hose it down with alcohol and just let it dry, just to clean the finger oils and everything off of it. After I get the switches adjusted, I will get the cam switch installed. I'll bring you guys back so I can show you what it looks like with the cam switch installed. And this is the cam switch so the cam switch comes out to here. This is the cam switch for the DC, AC, and ground. So as I'm moving the switch, you can see the cam moving just a little bit. That's actuating two more of those finger switches underneath. So yeah, that's about all I got with that. So let me get those finished adjusted and bring you guys back. Okay, and continuing on with our troubleshooting of the, what is this, 7A16. I hooked it up last night and I found out we got the 1 attenuator back, but the 5 attenuator was still missing, so all the 5s were dead. And I found out, so the 5 attenuator sits right here. Tilt this up. There we go. So the 5 attenuator sits right here, and I have signal fed in, and if I probe at this point, which is the input to the attenuator, I do not have a signal. If I probe at this point, which is this pad, where the signal would be injected from the bottom, I do have signal. So that tells me I did check continuity on this finger switch, but I don't know if you can see it, but just right here, the finger switch is not making contact with the pad. It's off just a little bit. So I need to get my Allen key out, and I need to do a little bit more tension adjusting on that finger switch, and then that should give us our attenuator back, and then we can run through the tests. So let me do that adjustment real quick, and then I will bring you guys back. We'll hook it up to the scope, and we'll put some signal on it and see if we can get it to do something. Okay, as you guys can see, I got the 5 section back. So in this particular plug-in, I haven't gone through the alignment yet, so I don't know if it's off electrically or not, but this was actually 100% mechanical failure. The spring tension on the finger switches was lost. I did have to repair one of the finger switches to get it working, but everything looks good now. Here's 5. 2, as you can see, I'm flipping it, it'll change up here. 2, 1, so we have 5, 2, and 1. Knock down the signal a little bit. Drop down. There's 500 millivolts, 200, 100. I'll have to look at 50 millivolts again. Probably have another switch that's out. Oh, no, I have another switch that's cranky. There's 50. Yeah, actually the DC ground switch was a little finicky there, so I'll take a look at that. So we'll bring the signal back up. Give it a little more. Okay, so there's 1 volt. $200. So we'll bring it up a little bit more. There's 100. There's 200. 100 volts of division. 50. Knock it down just a little bit. 20. 10. Now it's the plug-in moving in the frame a little bit while I'm figure out what's moving there. If I move the knob sideways just a little bit, I can get it to go away and come back. So I have another spring that needs tensioning. So let me figure out which one that is, and I'll get it back. This plug-in has seen a lot of use, and there's been a lot of hands in it. The screws are stripped out quite a bit. I can tell this has had a lot of work done to it. This is a lot of wear on these reed switches, so I may have to repair another one. It's in good shape for a lot of miles on it, but we'll see what we can do to bring it back. So let me get back to it, and I'll bring you guys back if something else interesting happens. Okay, on the spring that I fixed, looks like I just had a little too much spring tension, and it was causing an intermittent contact on the other side. So everything's stable. I'm going to let it run, warm up. Don't want to burn in the screen. So I'm going to let it run and warm up, just make sure the trace is stable and doesn't go away. And then if that is stable after a couple hours, I'll try to do a calibration on it and see what's going. But I think we brought this plug-in back to life. Was hoping it was an electrical issue, but it ended up being a mechanical issue. That is sometimes the way it happens. So I will let that run and see if there's any more work to do. Okay, well, we're back, and I had to tear the whole thing down one more time. Turns out on the 10 millivolt range, I did not have enough spring tension on the back side of the switch, because on 10 millivolts it's straight through. It doesn't go through any of the attenuators. Did not have enough spring tension on the clips, so a little bit of wiggle, just bumping the control was enough to cause it to come and go. But I've got it now, so I've got the attenuator all fixed. So let me knock this signal down a little bit. There's 5 millivolts of division, 10, 20, 50. Bring this back up. 100 millivolts, 200 millivolts, 500 millivolts, Give it some more signal. There's 1 volt, 2 volts, 5 volts. We can give it even more signal. And that's our stop. So everything's good. The cam switch had slipped a little bit. The noise you're seeing in the trace... No, I take that back. The camera can't see it. There's a little bit of noise that my eye can pick up. It's because of the readout. I have the readout turned on. If I turn that off, the noise actually goes away and the trace gets solid, so it's good to go. I did notice one other issue with this particular plug-in. If I take the variable adjustment and pull it out, you'll see the amplitude drops, and I can vary that. I can play with it. We should have a greater than 5 volt sign there, and that's not showing up. And I think I know why. Let me turn this off so I don't unplug this with the scope on. I'll pull it out of the plug-in and I'll bring you guys back on the bench and I'll show you what I found. Well, I have the plug-in back on the bench. What I found is I have 2 wires that are disconnected. And those happen to connect to these pins, which you guys actually can't see. Framing. So down on this potentiometer down here on this guy right here, there's 2 pins. Those 2 wires hook up there. There's some solder left on the lugs and there's nothing on them. So what I'm going to do is I'll get those wires reattached, and then I'll bring you guys back and we'll just check and see if I get that indicator that it's in variable back. And if I do, this plug-in is done and ready to go back. Well, not ready to go back into service, ready for calibration. I did a calibration on a 7A15 plug-in. This plug-in is actually identical. It's just faster. If you guys have an interest in seeing a calibration like that, if you guys have interest in calibrations and things like that, let me know, and I can do some more. But yeah, let me get those hooked up, and we'll see if we get the last thing that's wrong with this thing repaired. Yep, that was ultimately the problem there. If I hit the button, greater than sign, no sign, greater than sign. So everything is good. This plugin is actually done, ready for calibration. So yeah, we were able to resurrect it. We were able to bring it back, which is wonderful. So since we have repaired the device and I have a schematic, I figured I would just do a quick recap as to what actually went wrong. Every switch that's highlighted, I had to adjust the spring tension on because it wasn't making enough contact. Also, on this particular switch right here, it was very weak. The spring to the attenuator was pretty far gone. I actually had to add spring to this one. These are on the back side of the right underneath the cam switch. These are on the top side next to the attenuators. This is the matrix as to, given the position of the front knob, what's open and closed on the switches. This is that right here, when all of these are closed, this is that 10 millivolts a division section, so all the attenuators are out. That's why when I do a calibration, and also why it's marked with the black line, that's when none of these attenuators are switched into circuit. So the front end attenuators is a 10x, a 10x, a 5x, and a 2x. And it picks what it needs given the cam switch on the bottom, is how that ends up working. Yeah, so that was really all that was wrong with this one. Was a lot of hands have been in it. The screws were real stripped. Lots of, probably had a couple of technicians had to go with this one, but we were able to get it done. So that's going to go in the personal collection. I hope you guys enjoyed taking a look at this 7A16. The only real thing I didn't like about cleaning it up was there's still a ghosting of that permanent marker that they pressed on that one. If you guys have any questions, I check the comment section regularly, so feel free to drop me a line. If you have anything you'd like to see us work on in the lab, take a look at, have any questions about, let me know. I'll see what I can do to make a video happen, and we'll go from there. Thanks for all being here, and have a good day.